So in this class, we're building an operational amplifier. Operational amplifier, if you can think back to 211 or whenever the last time you used an operational amplifier, it has two inputs and one output, and it's a voltage input and a voltage output. So that is what we're actually going to be building, but that isn't true of all amplifiers. Amplifiers they can have two inputs and two outputs. They can have one input and two outputs, or two inputs and one output, or a single input and a single output. Their inputs could be voltage or current, and their outputs could be voltage or current. So there's a whole bunch of different ways you can combine those. In general, gain doesn't care whether the output is voltage or current. It just cares about how much that output has changed. This is not, I crossed this out because when we start talking about amplifiers that have current as output, then it's not delta V out, it's delta I out. But whatever that output is, whether it's voltage or current, it's how much that output changes over how much the input changes. And again, we're going to be doing an op amp, so it's going to have two inputs. It'll have differential inputs, but there's also op amps with two inputs and two outputs, an inverting and a non-inverting output. And so that would be considered a differential output. In our case, it mostly means two, but it has an additional meaning where the voltage in is actually the difference between the non-inverting and the inverting input. So differential means the difference between the two inputs, and it means that there's two inputs. A single input, single output. So your op amp could have a single input and a differential output, or it could have a differential input and a single-ended output, like our op amps will. Or it could be single input and single output. Dr. Prodnov says single input or single output. My textbook when I was in school called it a single-ended input and a single-ended output. So you'll hear that called different things depending on which textbook people used. So I mentioned again, op amps have voltage in, voltage out, but not all amplifiers have voltage in, voltage out. So we're going to be using a voltage in, voltage output amplifier, and hey, that's called a voltage amplifier. If you have current in and current out, then you have a current amplifier. If you have voltage in and current out, remember that gain is the output over the input. Actually, let's go over here. Let's go to the last row here. So if you have a current in, voltage out amplifier, and you put the output over the input, in other words, you put voltage over current, what's the units there? So whatever the output is over the input, that is actually resistance. So this is called, when you have a current in, voltage out amplifier, it's called trans-resistance amplifier or trans-impedance amplifier. Again, my textbook often called it trans-resistance, but Dr. Prodnov will call it trans-impedance. Trans-conductance amplifier is if you take the output, let's say you have an amplifier with current output and voltage input, that means current over voltage, and that's the inverse of resistance, so that's conductance, and so this is a transconductance amplifier. So we've got whether you have a single input or two inputs, and whether you have a single output and two outputs, and then you've also got a name of the amplifier, whether it's voltage in or current in, voltage out, or current out. So let's give those a try. This right here, what would you call it? This is a differential input, single-ended output voltage amplifier. How about that one? Current in, voltage out. So that is a trans-resistance amplifier. It's a differential input, single-ended output trans-resistance amplifier, trans-impedance amplifier. How about that one? Differential input, single-ended output, transconductance amplifier. And how about that one? That's a differential input, single-ended output, current amplifier. That's a single-ended input, single-ended output voltage amplifier. Transconductance, current, transimpedance. Now you've got a single-ended input, differential output voltage amplifier. Single-ended input, differential output transconductance amplifier. And if you put all the combinations together, that's how many different amplifiers you have. So those are the main naming conventions. Let's go to our first amplifier that we'll see in this class is this amplifier. And naming these, they have their own name too. This is a voltage amplifier. You can see it's a single-ended input, single-ended output voltage amplifier. Both of these are. It turns out they work the same way. The BJT generates current that gets thrown across the resistor, and current across the resistor creates V out. Same thing over here. The MOSFET generates current. That current gets forced through the resistor and makes V out move. But to name these, sometimes the names are a little hard to remember. So this is how I remember it. I look at where the input is, and I cross that out. And then I look where the output is, and I cross that out. And I say, what's left? And you say, well, it's not the base, it's not the collector, it's the emitter. The emitter's left. So this is actually a common emitter amplifier. Okay. How about over here? Give you 2 seconds to either pause your video or come up with an answer. So the input's on the gate, so it's not a common gate. Output's on the drain, so it's not a common drain. What's left is the source, so this is a common source amplifier. So how about this amplifier? What's its name? Okay, I'm not sure if I did animation on this. I think I did. So V-in's on the emitter, so it's not a common emitter. V-out's on the collector, so what's left? Common base. Okay, what about this amplifier right here? V-in's on the source, so it's not a common source. V-out's on the drain, so it's not a common drain. What's left is the gate, so it's a common gate amplifier. And how about this amplifier over here? Not a common base, not a common emitter, so that's a common collector. And common collectors have a whole bunch of names, and we'll look at all the names when we get to this in more detail, but just kind of the basic naming of these amplifiers, this is how it goes. And then for, oops, it's supposed to be a MOSFET. This is supposed to be a MOSFET here, sorry. I can fix that. All better. Okay, so this is not a common gate. It's not a common source, so it's a common drain amplifier. And those are the naming conventions, and next homework we'll have a bunch of these, and I'll ask you to figure out the names of them.